All right, here we are for the next segment of things, stoichiometry and gases. So here's the thing about gases. There will be two possible circumstances that you will have when you go to do gases. Either you are at STP, which is standard temperature and pressure, which is 0 degrees Celsius or 273 Kelvin, and 1 atmosphere or 760 millimeters of mercury. If you are under those conditions, then you really don't have to use your equation for PV equals nRT. You can just use the fact that there are 22.4 liters of any gas is the same as 1 mole. All right? So if you happen to be at STP, which is 0 degrees Celsius and 1 atmosphere, then you can do a shortcut, which is 22.4 liters is the same thing as a mole. If, however, you are not at STP under any circumstances, then you're going to have to use the equation PV equals nRT. So, a couple things about this. Regardless of what you do, remember that the temperature always has to be in Kelvin units, which is Celsius plus 273 is going to get you into Kelvin. And then the other thing that you have to remember is that R is either 0.0821 if you are using liters, atmospheres, moles, and Kelvin, or it is 62.4. Oh, I always forget that one because I never use it. Yes, 62.4 if it is liters, millimeters of mercury, moles, and kelvins. You can use either of these that you want, the 0.0821 or the 62.4. Help yourself. It's just that if you are in atmospheres, right, you got to use the 0.0821. If you're in millimeters of mercury, you got to do the 62.4. Now, if you're in atmospheres and want to be in millimeters of mercury, no problem. Just convert the one to the other. If you're in millimeters of mercury and you want to get to atmospheres, again, it doesn't matter. You just have to make sure that the units match with that. And of course, then don't forget from before that there are 760 millimeters of mercury that are the same as 1 atmosphere there. All right, so that's a quick little background of things that are going on for these units, all of which is just a way to get us from, again, our real world unit here to the moles, right? So real world is going to be liters and pressures and atmospheres and all that kind of stuff. That's going to translate down here into moles. So what do we have? It says how many grams of P4? So they want grams here. And what did they give you? They gave you 35 liters at 25 degrees Celsius, so that's 298 Kelvin. 35 liters at 298 Kelvin at 780 torrs. Oh, sorry. What's a torr? A torr is the same thing as a millimeter of mercury. So if you see torrs, don't sweat that. It's the exact same thing as a millimeter of mercury, named after Torricelli, who invented the barometer. So how are we going to take that information there and turn it into moles? Well, we're going to use PV is equal to nRT, or rearrangified, we're going to see that N is going to be the same as PV over RT. So we can get the moles if we use the pressure, the volume, the gas constant, and the temperature. So I'm going to go ahead and put in 780 for my torrs. And my volume is 35 liters, so I'm good to go there. Because I'm in torrs, I've got to use the 62.4, and that's liter torrs per mole Kelvin. And then the temperature is 298 Kelvin. So when you plugify all that in, if I've done my math right, you should end up with about 1.47 moles here for this. Please, again, keep in mind that we have not taken that 5 into account because right now it doesn't matter. But we want to get over here to that guy, so now it matters. So I'm going to go from a 5 to a 1, so I got to get smaller. Multiply by 1, divide by 5. So you should end up with about 209 or 0.294 moles of this stuff. Now I want to go from moles to grams, so I do it the old school way by multiplying by the molar mass, which is about 124 grams per mole. And if you do all the math on all of this correctly, you should end up with about 36.5 grams of P4.